First, they take all the details are and instruction and information permanently stored in the hard disk. Then when we run some device program which saved in the computer, the information or the data will take from hard disk to main memory, or normally we call random access memory, RAM. Then from RAM to the cache memory, and from cache memory to the registers. Okay. Then why they use this kind of technology? Because the hard has more storage and it can store the things permanently, but it is very slow. Okay. But the main memory, something like this, right? Then hard disk, from hard disk to main memory. From main memory to cache memory. Then from cache to register. Okay. Then this cache memory also divided into some categories like L1 cache and L2 cache. No need to think about that in this stage. Okay, the thing is this is permanent. Hard disk is permanent. Okay, and it has high storage capacity. High storage capacity. Okay, permanent, and it has high storage capacity. Then we consider the main memory, cache and register. All of these are temporary. That means they can't store the things permanently. This one, okay? All these are temporary. Then we call that volatile memory and non-volatile memory. Volatile memory means what? Once we turn off the computer, or once the program is finished, once the process is finished, data will be removed from this main memory, cache memory, and register. Therefore, we name this as temporary memory, or the technical word is volatile storage. Okay. The technical word is volatile storage. Okay. For this one. Then main memory, cache memory, register. Temporary, the technical word is volatile storage. Okay. Then hard disk is permanent. Okay. Then technical word for this permanent storage is non-volatile. That means even we turn off the computer or even the process is finished, data will be stored inside the hard disk. Okay. Then if you compare the hard disk and main memory, okay, the first thing you have to understand is hard disk is permanent or non-volatile. Okay. Non-volatile storage, and main memory, cache and registers are volatile or temporary. Do you understand that point? Do you understand the point?
Yes.
Okay. The second thing that you have to understand is, if you compare the hard disk and main memory, the storage capacity of hard disk is higher than main memory. Okay. Then, but speed of the main memory is higher than hard disk. Okay. Then we mean RAM. Okay. And then access memory. Okay. Then if you consider hard disk and main memory, hard disk has high storage capacity but slower than main memory. Okay, main memory has low storage capacity than hard disk, but it is faster than hard disk. Do you understand the thing? Then if you consider this main memory and cache memory, main memory has, or RAM has, high storage capacity than this cache memory, but the speed of main memory is slow, or the main memory is slower than this cache memory. Okay. Or if I can explain the same thing like this also. Cache memory has low storage capacity than main memory, but cache memory is faster than main memory. Do you understand the thing? If you consider this cache memory and registers, cache memory has higher storage capacity than registers, okay, but slower than registers. Okay. Then if you consider from left hand side to right hand side, the devices. Okay, when you move from left hand side to right hand side, storage capacity gets reduced, but speed get increased. Am I correct? Storage capacity get reduced, but speed get increased. Am I correct or wrong?
Yes.
Yes. Then in this case, okay, this is the technology they use. Then if the processor or registers are available inside the processors, then if processor try to access the hard disk directly, what will happen? All the system will be very slow. Why? Hard disk is very slow storage component, very slow storage component. Okay, therefore the processor can't directly access the hard disk. Okay, then processor means the registers are also inside the processors. Okay, I will explain that in that lesson. You have to keep in mind that registers are available inside the processor. Okay, then if you consider the processor, it is like this: processor, CPU, central processing unit. Okay, then here you have registers, then ALU, arithmetic and logic unit, and CU. CU is the control unit. It will control all the things in your computer. Okay, then ALU. Okay, control unit control all the devices, or all the component in the computer, input devices, motherboard, hard, and all the things are controlled by this control unit. Okay, then this ALU is used to do the processing part, like we call that arithmetic and logic unit, used to do the calculation and processing part. But when ALU doing the calculation and processing, the data should be stored by some component. Then the data need to process by the ALU is temporarily stored in registers. Okay. Then once to process in the ALU, the data should be stored in somewhere. Okay. The data that which are going to process in the ALU temporarily stored in this register, and once ALU completes the processing, the data again temporarily stored in the registers. Okay, the data which need to process by ALU temporarily stored in registers, and after completing the processing, again the data temporarily stored in the registers. Okay, then once you access a program that you have saved in your hard disk, it will move from hard disk to main memory, from main memory to cache memory to register. This one, okay. The same register only I have marked here also inside the central processing unit. Okay. Then again, hard disk has high storage, but it is slow. Therefore, only required data will be taken from hard disk to main memory. Why? The main memory has low storage capacity, but the speed is higher than hard disk. Therefore, only the required things will take from this hard disk to the main memory. Do you understand the? All the data which have stored in the hard disk is not useful right now. Therefore, only the required things will be taken from this hard disk to main memory. Okay, to increase the speed, because no need to find all the things. Only required things are stored in main memory. Therefore, we can access that data more fast than hard disk. Do you understand the thing?
Yes.
Okay, then here main memory to cache memory. Then main memory, the storage capacity is higher than cache memory. Okay, then in this case, okay, from main memory also, only most required things take to the cache memory. Then there are some data is available in main memory, but we can't process all the data which available in the main memory right now, and it is not need to process all the data which is stored in the main memory right now. Okay, some programs are waiting for user response. Okay, some programs are waiting to give the output in the printer like that. Okay, therefore some programs are not need to run right now. Therefore, only the required data or programs will be taken from main memory to cache memory. Then what will happen? Again, the speed of the cache memory is higher than main memory. And only most required things have taken from main memory to cache memory. Then again we can increase the use this technique to increase the speed. Okay. Then from cache memory to registers. Again, all the things we have stored in cache memory is not need and can't process in the processor right now. Therefore, only required things will be taken from cache memory to registers. Again, in this case, registers are more faster than cache memory. Okay. Then once we process that set of data, and once we release that data from the central processing unit, that means after we process that data by ALU, and we transfer that data to register. Then once the job is finished, we will release that program or the relevant set of data from the central processing unit or processor. Simply from processor, once we finish the job, we can release that data. Then again we have chance to process another set of data. Then another set of data will be taken from cache memory to register again, and they can process now. Then these registers are available inside the central processing unit. Okay, the cache memory are also associated with the central processing unit, but these are directly available inside the central processing unit. Okay, then for example, think if the CPU directly access the hard disk, what will happen? It will take long time to process the data because hard disk is very slow. Am I correct? For that case, only they use this kind of technology. Then once you input the data, the input data will be go to the main memory or simply random access memory. Then if you need to store them, you can store the secondary storage. Simply I can call hard disk. Okay, the hard disk. I'll mark that here. Simply we can call registers. Okay, then main memory. If you need to store them permanently, you can move that data to hard disk. And once you need them, you can take that again from hard disk to main memory. Or simply I can tell random access memory RAM. Okay. Then, if you need to process the data will be sent from main memory to register. Okay, between the main memory and register, there is another storage unit called cache memory. You have cache like L1 cache and L1 cache and L2 cache. Then, according to the diagram which given in your textbook, they haven't mentioned that, but you have to keep in your mind there is another part or another component called cache memory is available between this main memory and registers. Okay, I will mark that here. Okay, then once I finish this explanation, you can take a screenshot of this. Okay, then cache memory. Okay, between this registers and main memory, you have cache memory. Then the data. Once if you need to process the data will be sent from main memory to cache memory and from cache memory to registers. Okay. Then data will be stored inside the registers until the processing part is done by ALU. Okay. use like our brain, it can do the arithmetic and logical processes. Okay, that is the arithmetic and logical unit. It can do calculation and some processing can be done by this ALU. It is like our brain. Then after processing is finished, the processed data will be sent from ALU to register. Okay, then again from registers to cache memory and cache memory to main memory. Then if you need to store the data, you can store that in the secondary storage in hard disk. Or if you need to take the data as output, you can output data from main memory. Then if you need to take data which you have already saved in your computer, and if you don't need to process them, then directly you can access them from secondary storage and you can take the data to main memory and you can take the output like that. Okay. Then in this diagram, they have used this dotted line for data and instruction flow. Okay. That means the data which we need to process, data that which we input, and data which we take as output. They are the data and instructions. Okay. Then they are mentioned in dotted line. See here from input device to main memory, main memory to secondary storage, and secondary storage to again main memory. Then main memory to registers. Oh, through the cache only we send to the registers. In that case also we can use the dotted lines from main memory to cache, from cache to registers. Then this registers to ALU, ALU to registers after processing. Registers to again cache, from cache to main memory. And if you need, again you can send the need to save, you can send secondary memory, or if you need to take that as output, you can take it like this. Okay. However, these dotted lines are data and instruction. Okay, the data we need to process, data which we input, the data which we need to save, or data which we need to take as output. Okay, but these continuous lines are commands or controls. They are used to control the computer. Okay, see here, the control unit is also a part of central processing unit. Using this control unit, they can control all the computer, all the components in the devices, input devices. See here, these control signals are directly, okay, that control signals from control unit are directly connected to all the devices. See here, it has connected to input devices, okay, secondary memory, main memory. See here, registers, ALU, output device, then entire computer is controlled by this control unit. Then these are commands or control. Okay, do this by your output device. Okay, now do this task by monitor, like that. They give the control signals. Now turn on the computer fan if the heat is high, like that. Now reduce the speed of the fan, like that. All the control signals are sent by this control unit. That is done by control unit. It has the ability to manage the computer, entire computer system. Okay, but we need to process the data. Then we need this instruction signals, these dotted lines. But to run the computer smoothly and to do the functions of the computer, it should be controlled. Therefore, the computer components are controlled by control unit. By that control, the computer give us chance to process the data, store the things, and take the outputs. Okay, the data and instructions which we need to process or input, output, or store are marked in dotted lines. But as a system, the computer should be managed or controlled by some units. That task is done by this control unit. See here, control unit. Okay, then no need to think. That means there is no difficult thing to understand in this control unit, because the control unit, from the control unit, the control signals or commands are directly connected to all the devices. Then the thing that you have to understand is the data or instruction flow in dotted lines. How the data how the data flow from input devices to main memory. Then from main memory to output device. That is the thing that you have to keep in your mind, because the commands or control signals are simple, because from control unit, commands and control signals are directly transferred to all the devices. Now here, okay, then I think you have some idea about this computer function of a computer system. Okay, then answer for the fourth question is, second one, the data will move from, I will explain that, yes, using the board. The data will be, first data will take from hard disk to main memory, okay, main memory to cache memory, from cache memory to register. Okay, then we can